Good
This
morning.
conference will now be recorded.
Can you just tell me if I'm audible and you can also see my screen?
Yes, sir, it is audible, sir, your voice.
Yeah, thanks a lot. So, thanks for everyone attending this. Let me just share the screen and introduce myself. Just give me a second to set everything. Okay. My name is Sandeep. I've been working in the like DevOps since 12 years. So I've got into like migrating the on-premise setup to the AWS cloud, and I'm working in various firms like last 12 years, and I have got good experience in almost all the DevOps tool along with the cloud. And I have been using the AWS cloud since 10 years, and have been training like almost since 5 years, in the AWS and AWS Solutions Architect certificates, and even the DevOps also so that's from me. So today, I know like you're all from the different backgrounds. Like someone could have already been in the DevOps and they want to understand the cloud and how the cloud will help in the career, or if they want to upskill themselves into like adding the cloud to their career. And like some other people could be coming from a different backgrounds, like they could be QA and there could be the students, or like any kind of people will be there for this course. So this is not something it is only targeted for the DevOps to learn what is cloud and to understand the AWS cloud. It's like something like I target this around the solutions architect. So in this course, once you have learned the AWS along with like complete course, so my intention is like you'll be able to handle the AWS solutions architect certificate. So the course is intended and exactly looked into those lines, like what the syllabus of what AWS solutions architects wants. So that is about what the course teaches you and what it is. So here, for some time, we'll spend around understanding what is a cloud, why the business want to move into the cloud, and what is an advantage if they want to move to the cloud. Even if your current organizations are already looking into the cloud, like these days, if you look into any of the applications or anything that is already moved into the cloud and automated into the cloud and all that. So this is a good opportunity to learn the cloud, and every particular job role is asking for a cloud. And if you are good with the cloud, then the opportunities that you get in the market is very, very high. Like AWS is a hotcakes, and you also you know how the AWS is being utilized for various business and all that. So now we'll try to understand pretty basics of it, and later what I'll tell you is what if you don't have a cloud. For example, if you want to build a Facebook or Instagram kind of website, if you don't have a cloud, what kind of things that you need to do on your own on-premise setup, and if you have a cloud, what kind of advantage that it gives for the business to move on to the cloud. So that will give you a kind of clarity rather than me just going into the cloud and showing you this service is for this one and just giving an introduction around that. I'll try to come up with a kind of problem definition and see how the cloud will help us to completely move any kind of application to the cloud and leverage what all the things that it has. Okay, that's my whole intention of this demo. And and you can ask me any questions at any time. For example, if you want to stop me at one point, and if you want to ask anything, you can just ask me, and I'll tell you the complete things that I'll tell in this course after this demo, and so that we can have a question and answer around that also. So just spare some time with the slides so that it will give you an insight of what is a cloud and why we need to move to the cloud. So firstly, I'll tell you how do the websites work. So generally, this is a common scenario where you have a client, a network, a server. This could be sitting anywhere, like it could be an on-premise or cloud or anywhere, and people try to connect to that using an IP address, and server has an IP address or a DNS or anything, but everything goes via internet and connects to this particular server. So this is normally what we analyze any kind of application. If it is a web application or anything, we have this in the mind. So if you come to internals of how the things works, so any server will have these things, like it needs to have a compute. that is like CPU and all that, and also the RAM, which combines to form a brain kind of thing. So where similar to the human brain, where it does all the computations and anything to run your servers or any application servers or anything. So a server will have all these things. It should have a compute, a memory, a storage data, and also a database for storing everything in a structured way. So whenever we talk about any server, it could be a web server, it could be an application server or anything. We think in these terms. And it also needs networking finally, because the whole intention is you host an application there and people should be able to access that, and should like your business should grow. So that's the reason a server is composed of these things and all that. And like these are all connected finally in the network terminology. If you say they have routers, switches, and everything is connected, and you have your clients like Firefox browsers or mobile applications that you want to connect to the data, like that you want to connect to the servers, and the data flows in this way. And I just want to tell you how generally traditionally an infrastructure is built. As I told you, you have a server, routers, and all these things. Firstly, let us understand how the traditional things are built. Later, you will see what's the advantage of the cloud instead of the traditional way. So generally, if you look into any of the companies like the Google or Facebook or any companies, if they have an idea and they want to do something around that, firstly they need to purchase some infrastructure and all that. So people tend to start everything from the home garage. Like they get the servers, they go to the market and they purchase the servers with all the compute power and the CPU and memory and all these things. And they start building the complete server in the home garage. And once they are into the business, like the people are using that, the home garage is not completely sufficient, because your business is growing. A lot of people are trying to access your website. If it is an e-commerce, they're trying to buy the products and everything in that. Then you need to move into some other place. Like it could be an office where it is expanded, where you have a completely dedicated room, which is called a data center, where you run the servers. And now the users should be able to connect to these servers and get their applications. But in these kind of traditional like approach, you have a lot of problems. Like let's see what are the problems that you face. Firstly, you need to pay the rent for the data center because you have their missions there. So you went and you purchased a physical servers with some money, and then you need to rent for the data center and you need to put it there. Or you can also purchase the same kind of servers from the data centers also. They will also provide you that. And you need to pay for the power supply, cooling, maintenance, and all these things. And let's suppose your e-commerce website is hitting a lot, like a lot of people are trying to come there and purchase the products and all that. Now you want to upgrade the hardware, like you want to replace the hardware which is there, and for which you need to have the downtime. During those times, the users will not be able to access the website, and there are a lot of problems here. And replacing the hardware, it won't work straight away. Like you need to like once the application is up again, it needs a lot of downtime and things can go wrong at any level. And scaling is also limited. Like you can't scale. Scaling is nothing but adding more hardware or the resources so that you cater the number of requests that is coming to a website or your application or anything. So you need to add the RAM, you need to add the CPU. Everything is limited in a kind of traditional IT approach. And you need to hire a team which will be 24/7 monitoring your infrastructure. They need to look into the problems if something goes wrong. And if one particular component goes wrong, all your application can go wrong, which is a very serious thing these days. And you need to know how do you deal with the disasters. Let's say you have taken your website or everything in the one particular data center which is residing in one particular location in a city, and if something floods comes to that area, and if power goes off, or if anything goes wrong, you're completely out of your business. And it could be a tremendous consequences if you have these kind of problems these days. So once you're in the business, you need to always see that your application is up and running, and the users are able to seamlessly get the services from your application. These are the many factors that literally determine whether you are in the business or out of the business. It could be a startup, it could be a big companies, but these are all the regular problems that they need to look if they want to stay ahead. So now let's introduce the cloud computing. So instead of taking care of all these things, you can hand over these things to something called a cloud computing, where it takes care of everything for you. So it could be an AWS, Azure, or GCP or anything. But I'll tell you precisely why you need to consider the AWS when you compare to the other vendors also. But the cloud computing is something which gives you an advantage of all the problems that we are talking about. Firstly, it's an on-demand delivery. It's like pay as you go. Like if you want, you have an idea, you want it's a kind of machine learning idea, let's suppose, and you don't know whether that particular algorithm runs properly and it can serve your needs or all that. So instead of traditionally going to a data center and purchasing the servers and putting your algorithm there and running the things, and if things are not working, you have spent a lot of money and all these things, right? On the servers and everything, and where it's sitting ideally now if you're not into the business. But in the cloud computing, you just go to a some kind of web application or web access where you directly go and create what kind of, like for example, if you want to have the machine learning, you just create on something called machine learning service. You put your algorithms within 1 hour, you can test it out everything, and using that, you also you'll be on the business also. So it's like pay as you go. It's like something like power bill that you use in your home. So if you have an appliance and if you use it, a power bill is generated. If not, the current bill is not generated. So in this way, you only pay as you go. And one more thing is you can provision exactly the right type and the size of computing that you need. So it's not that you may think your website is going to be hit by millions of users someday, and you try to purchase the hardware based on that. And later, if the things are not going well, you can't sell it off everything. So there's a huge headache for any company to start up. But if you look into the cloud, you can just take whatever the size of computing power you want. For example, 4 CPUs, 16 gigs RAM. You just take that, you put your application there, you run that, you serve the users. So if something that if the users are increasing more and more, then you scale up with single click without taking down your application. So all these headaches will be taken care from the AWS itself. You did not do anything. You happily put your application. You can focus on your business and all that. And even the companies also wants this kind of approach rather than thinking of a traditional way. And there's a simple access to servers, storages, databases. For example, if you want to create a database, within a click, you can just go there, click on it, create a database, and the application use the database. Or if you want to have a storage, like it could be any terabytes of the storage, within a click, the storage is ready and you can use it for your business. So in this way, all the things which are very difficult to manage in a normal traditional on-premise setup in a data center, the cloud has gave a way to, in a single click, you can do all these things. So that's the reason, if anyone wants to start the business, or if you have any complex on-premise setup that you want to manage much into the infra and all that, the cloud is there for anyone. They can just go there and they can move the on-premise setup to the cloud and they can start working on that. And finally, AWS maintains all these things for you. It has a very good network connected hardware and everything, and so that you can use the AWS for any particular purpose and provision that you want to have. So now you have moved all the office to the cloud. So if you see, there are a lot of companies already using the AWS service. It's a very, very famous one. Complete, like for example, Netflix is completely built on the AWS, and the Dropbox is something which is also built on the AWS. So you can think the cloud service is something where you just go, how you use an email service. You can just go to AWS console, create the databases, servers, and everything in a single click that you need. And you only pay for what you use and how much amount of time you use. It's not that your infrastructure is sitting in the cloud and you just go on paying whatever you want. So these kind of advantages are there. So, and there are some deployment models of the cloud. You have something called private cloud. Let's suppose you are some kind of banking application or insurance application. So your customers' data is very, very secure, and you don't want to expose that to the any of the cloud. Then you have something called rack space kind of clouds, or you have, if the if the data is fine, if you want to go to a public cloud, then you can go with these kind of the AWS, GCP, and Azure, or these kind of examples. And many people are going into a hybrid cloud of approach. What they do is, all the data, all the secure data will be there somewhere in the on-premise, and AWS can leverage all these things, like it can connect to the on-premise and it can get the details whatever you want. So AWS again supports these kind of models also. It's not that you want to completely go into the AWS, or you can have a mixed match of hybrid cloud. That's the reason this is one of the very popular cloud and people are trying to use it. So with all the problems that we talked about in the on-premise, firstly you move that to the cloud, and only the data that you want to have, the secure data that you want to put in the on-premise. So you can have this kind of setup also. Okay, first let's before going to these advantages of the cloud and all that, let's try to build a small application, a Facebook kind of application, and let's see AWS how the AWS solves that problems. And okay, so I just these are the services of the AWS. I'll come back to these things later. So let's try to do this one. Let me just present this and let's try to understand. Like, firstly, it's fine that I told you some advantages of the cloud and what it gives and all that, but why the business needs to move into the cloud? And if you want to understand at the application level, till now we have looked into the infrastructure level. We have certain challenges in the infrastructure and we want to move into the cloud. That really solves the things. But what exactly at the application level that it really solves us? So that let's try to understand. So if you want to build a Facebook kind of like a website, firstly, you need a server, like it's a normal server, and which is attached to some hard disk where you want to put everything like the images or like whatever you see in a Facebook or a Instagram that you want to have something like this. The people outside, you have a network where your servers are running. The people outside tries to connect to your web server using an IP and all that. So if you don't have any DNS in place. Next, if an application is not exactly a web server, it needs more components. Like you want to segregate the business logic to some other place so that these two things work together. So you need to have an app server, which is also hosted on a simple virtual machine, which is having a hard disk. So this is a simple setup that we have. And next, everyone knows what we need. It's a database. Like if you want any a three-tier application to work, you'll have a database sitting here. You will have an application server like a WebLogic or Tomcat or WebSphere or any kind of application server sitting here. And there is a web server like Apache or something which is serving your website. This looks good. The people from outside are able to connect the facebook.com, or if it is an IP, based on the IP, they'll first connect. And here they can upload their images or look into the posts and all that, like a simple kind of website. Let's try to understand. So we'll come into the complexity later. How do you upload and all these things? Now you want to scale this. Let's suppose today only 100 users are using. Like tomorrow there will be thousands of users using your Facebook.com and a social media website. And now problem comes like scaling. As we told, even in the on-premise setup also, this is a very big problem. Like how do you scale the infrastructure when there are more and more users and when there are more and more requests coming there? So for that, generally in the on-premise also you do this kind of approach. You need to add more servers, like which again serves as a web server or app server. So you have a setup like this. So these two VMs will be serving your web server. These two VMs will be serving your app server. This is fine, but how do you route the traffic? For example, if an user comes with an IP address, he has this VM IP address. He doesn't have this VM IP address. You need to have something which can balance the load. For example, one request to be sent to this one and one request to be sent to this one. So then we introduce a new component called load balancer. Then the people are trying to access first the load balancer, like they can have an IP of the load balancer, and the request hits the load balancer. From here the first can go here, second can go here, and now you have a fair amount of architecture, which is a three-tier, and you have a load balancer in place, so the things are going smooth. Now everyone can't remember an IP address, you introduce a DNS here. So now you put a social media website name like facebook.com, fb.com. The people will use that one in their browsers to connect this. They hit the load balancer. From here the load goes to this one. So in a normal on-premise setup, you need to take care of everything. Firstly, you need to create the DB like MySQL, Oracle, or something like that, and these VMs you need to create. After that, you need to create a component called load balancer. For that, you'll have a software called HA proxy. So you need to take a Linux machine. On the top of Linux machine, if you install HA proxy or Nginx, then it will act as a load balancer. Then this DNS part also you need to take care. You need to go to GoDaddy or Namecheap or someplace where you need to purchase a domain and where you need to tell the domain to hit this particular load balancer IP whenever someone tries to hit the facebook.com. So this is a normal on-premise setup if you want to set it up. Now there are other things. The Facebook is not only this one, it needs to serve more things. Like for example, it needs to have the database also, a scalable database. It's not that you just have that only relational database. You need to have some kind of non-relational databases for storing your user information and getting the others user information. And there are many use cases if you are going into a non-relational database. So you need to introduce that for scaling and all that. And after that, if you see, you need to have some caches also to make the SQL queries very faster, because you want to decrease the time of latency and all that one. And one more thing is, these hard disks that you have attached are they have a limitation. For example, it could be 100 GB or 200 GB or 1 TB. But if you go on updating your posts like images, videos, and all that, this will soon fill up, and these web servers will itself get affected, right? You want to move into some other place. So you purchase an external storage. In an on-premise setup, it could be a network file storage or something, where you create a storage and you send all the images and everything to here. So now people are able to access the Facebook. They are able to upload the images and everything to external storage, and they have a database which is something scalable in this way. And you need to take care of everything. You need to install MongoDB or some kind of DB which has non-relational DB, and also this relational DB. And this DB cache also you need to maintain. You need to install something called memcached, Redis, or something which will cache your queries and which will serve the application. So all these, each and every component, the people needs to take care when it is in on-premise or when it is in a normal data center. So next, you need to have a content filter also. Like you will not upload any kind of images. There is a content filter which looks like only images which suffice the policy should go into the storage and all that. And now comes the revenue part. Like if you see, then Facebook always relies on, yeah. Someone has a question. Okay, if you don't have, can you just mute yourself, or you can type your question also? It would be fine. So we're just trying to understand, what if you don't have anything, a cloud or something, and let's see how the cloud solves this problem. That's the whole intention of this scenario. Now you'll have ads. Like for example, if you just scroll the Facebook, generally there are certain kind of ads that is targeted per user based on their scroll, like what kind of things that you like and all these things. Yeah, Aruna, please tell me. Like, sorry, if you have any questions, you can just mention that. Okay, so let's see how we can add that. So for that, we'll add something called clickstream analysis. So what generally we do is, any kind of social media website like Instagram or Twitter or Facebook, based on what kind of clicks that you do, what kind of things that you save, based on that, they run some kind of clickstream analysis, and they try to give you the targeted ads. So for that, they need some kind of business intelligence, data warehouses, and everything. The Spark, Hadoop, big data. They take up all the details about what you like, and how you scroll, and all the data are captured, and they run some kind of business intelligence around that. And based on that, the ads are generated for you. So this is how the things will be there. Okay, and now let's try to, and people also, like some people will use a web browser, some people will use a mobile based app. Like we try to open the Instagram, more people try to use the mobile rather than the web browser, right? So now if someone saves a image there, or if someone saves a video file there, so you need to have some kind of converter, so that even the mobile can also see those things. Like it's like there is mp4 convert, like mp4 to some kind of M package or some kind of converters, so that the mobile users may also consume those kind of data. So this is kind of architecture we established here. So now the people are able to access the facebook.com, and this architecture looks good. And all these components, again, in on-premise, you need to take care. Like you need to write a scripts to convert the videos, or you need to have your data warehouses. You need to install the different kind of things for the storages, business intelligence, and all these things. And now let's suppose if you have one particular video or something which is viral, like many people are, like there is some video came up and that is very viral, and Facebook wants to put that very easy first, so that that can hit first instead of going into all these things. Then we have something called content delivery network. Facebook needs to maintain this, so that people will hit here, and the viral videos and the things which they consume a lot will sit here instead of directly sitting on an external storage. So these kind of architecture will be there. So if you want to have that caching and to speed up your access to the facebook.com or Instagram and all that. So now we need to take care of some other things along with this. So let it be like you need to chat with the friends, and you need to have your email integration, and like there will be mobile notification if someone likes your post and all that. So for that you need to integrate some kind of things with the app servers and do all these things. So if you see, with all these things, you have this kind of architecture that you need to take care of every component of these things in your normal on-premise setup. So this is something, if you want to build these on infrastructure in your office, it would take a lot of time, and even in the data center, you need to take care of each and everything. There are many kind of failures that can happen here. If the load balancer goes down, everything goes down. The people can't access the things. If CDN goes down, the load on your complete website is very, very huge, because they need to travel till here to get that content. And if any of these Spark or business intelligence fails, the user can't get ads and all that. So to be in the business, there are quite, these things are very much important, and the architecture looks very complex, and you need to monitor these things every time. You need to monitor all these things. You need to monitor the load balancer, VMs, databases. If databases gets filled, your job is to again scale it up. If disks fill here or anything goes wrong, you need to monitor the dashboards continuously. So to establish this kind of architecture in any kind of on-premise setup, it's a very difficult and a nightmare. So let's see how the cloud will give you different kind of services to establish this complete facebook.com on an AWS cloud. Then you'll understand why a business needs to move into AWS cloud. So firstly, we'll go on replacing each and everything here. Firstly, a private network. So AWS has something called virtual private network, a VPC. So you create a VPC and you put everything inside that, so that you will have your own complete networking, isolated networking and all that. Okay. Now let's replace these VMs. So these VMs are replaced with something called EC2. This is a AWS gives you a servers instances. We call it as EC2, Elastic Cloud Compute. You replace the VMs with these things, and also these disks are there, right? So you can see these disks. These are replaced with something called EBS. It's called Elastic Block Storage. So it can be like you can just add and you can replace the disks and you can do whatever you want. Like it's a without downtime of the application, you can increase the size of the hard disks and all that. Okay, and you have the load balancers here. Like if you see, we need to have the load balancers and auto scaling. This is what AWS gives us. So if I go here, so you can increase more and more these EC2 instances about the auto scaling. So you can write something like that. For example, if the users are 1 million users, add one more instance. If the users are 10 million users, then add 4 new instances to this. So in this way, you can add more and more instances with writing these policies. Like if CPU is more than 50%, add one more instance. So that is the point we call it as auto scaling. Without your intervention, the scaling happens automatically and your business will always be running. It will never be down. And here for the DB, you have something called RDS. So you replace this particular DB with an RDS and NoSQL with a DynamoDB. And you need not think of anything like these things get increased at the RDS. You need not think of installing the MySQL and maintaining that, taking the backups, taking the snapshots. Everything AWS does that. So that's the reason you try to always move into the RDS and all that. Just a second. Okay, we just try to replace these things, that is servers and the databases and a networking, nothing more than that. Now let's go to other things also. So now we replace the DNS, that is with the route 53, and load balancer with an elastic load balancer. So if you go with an on-premise, as I told you, for this load balancer, you need to install the Nginx or a HA proxy, and you need to take care of the things. For example, if you have installed the Nginx, if suddenly there is a spike, let's suppose you have an e-commerce website and there is an offer, like you have introduced some kind of big billion day or a Black Friday or something, and the people will try to hit your website more and more. But in an on-premise setup, your load balancer will fail that. Like if there is 1 million hits, it can't handle that many amount of hits, and complete application goes down. But in the cloud, you have something called elastic load balancer. So it is again elastic itself. Like you add any number of users, it should be able to automatically scale and serve that users. So you have this thing in the cloud. And the DNS is again replaced with the root 53. Let's replace these things what AWS has. So now if you see, the external storage is being replaced with something called S3. So this is a kind of object storage in the AWS. And it like you go on adding the images to that or the videos to that, it can handle. Like it goes around petabytes and TBs and it scales according to the requirements that you have. Now, wherever you see the external storage here, and here, you can replace that with an S3 bucket. And related to these things like the content filter, AWS has something called recognition. You can just add it out and to your application, and it will just add it. So, and let's replace these things also for Hadoop and all that. And yeah, one more thing for the videos converting, you'll have something called Lambda, which is a function as a service. You just write some Python script, it does all the things for you. You need not give a server to run the Python also. So we'll come into this thing. It's a serverless component, we call it as. And if you replace all these things, there is something called Kinesis, EMR, Redshift, Glue for ETL. So all these services will make sure that you have the big data, business intelligence, and a kind of data warehousing solutions in the AWS. And this is an ETL kind of thing, Glue, which makes sure that, for example, if you want to look into the posts of other guys, you can just go there and look, right? So all these things come from the Glue and ETL kind of concepts. So now for this business intelligence, this part will replace with something called Athena and a QuickSight. So this particular thing, if you see the Kinesis, EMR, Redshift, Athena, and QuickSight, these are all the 5 services which glue together, which combine together, which gives you, if your user clicks and based on his action, the ads are generated, the revenue is generated to the Facebook. So this is very important, and this has a huge kind of business intelligence and the things goes on here, and this to be take care. And AWS has these services which are again scalable and which works out of the box for you, and you can integrate all these services with your application. Now let's try to look into this one, the CDN part and the other parts which are sitting in the left side here. So if I come here, so all this CDN part is replaced with something called CloudFront in AWS, which has something called edge locations, and which makes sure that, for example, if you're opening the Instagram from the India, this edge location will say that it will connect to the nearby data center in the Bombay or Hyderabad, so that you will get a website nearby. So it would be something like this. For example, if you're using the Netflix or Amazon, the content should be based on the locations, right? All these things will be from the edge location. So AWS gives these kind of services so that your application stays close to the users. So a guy from the US will not travel, like his network latency won't travel till the India data centers and get the website. It will be edge locations are located all over the world for the AWS, and he'll get the website from the nearby edge locations, like sitting in the New York or somewhere. And here, if you see the notifications, email services, queue services, everything is again moved to the AWS. That is a simple notification service, simple email service, and a queue service, and something like these things. And you have a CloudWatch, which can monitor everything. It will monitor the edge locations. It can monitor the Lambda function sitting here. It can monitor the EMR. It can monitor the RDS. So you can monitor the complete infrastructure, your application, and everything with the CloudWatch. So this is what, like, it may look complex at one end, but if you try to replace all the services what AWS is giving you, like if you can see this, you can completely build a normal social media website or anything in the kind of services AWS gives you. So that is what my whole intention here is, to understand a normal architecture in an on-premise, and if you come to the AWS, how it exactly looks and what kind of services that are there in the AWS. So now you can think like what kind of, how many services are in the AWS and how you can utilize all these services and all that. And now you get some more questions, like for example, how do you automate this or all these kind of things, or how do you maintain the security of all these things and all that. So for that, AWS has many kind of things. So firstly, if you look into the security aspects, they have these things. There is something called IAM security. So based on the users, you will give, like, developers should only access these things, or a QA guys should only access these things, some kind of that. And there is something called KMS, which will encrypt the data on everything. For example, if you have a data on EC2 instance here, like in a hard disk, it will encrypt all the thing. Or if you have the images in S3, you will encrypt all the images so that even if there is an attack, they can't see the images and all that. And you have WAF, it's a firewall and all these things. So anytime if you move your application into the AWS, you need to take care of security also. That's the reason this particular slide shows you what kind of security AWS gives you. So there is a security in CloudFront, that is WAF. So there is no DDoS attacks or something here. So it takes care of everything. Now let's move into how do you deploy them. For example, you need to create this complete stack for development, or a QA tells you I need a separate stack so that I can test everything out there. And there you need to have a staging, you need to have a production. So you need to have various stacks of the same infrastructure. So for this, AWS gives you a resource called CloudFormation. So using this CloudFormation, you can create all the things that I've shown you in within half an hour or 1 hour. So it creates all the services that you need in parallelly, and you can have any kind of stacks that you want, a QA or a dev or anything. And this particular CloudFormation you write in a kind of templates. It's a normal YAML files so that anyone can write this. And now if you write any code, you need to have something called where you can have a repository, right? You need to have a Git repository where you can put your code. So for that, AWS has something called code commit. You put all your CloudFormation code and everything in a code commit. Even a normal developers also can put their application code in the code commit. And for the build and release, like we call it as CI/CD these days, a continuous integration and continuous development, where you need to have a tools which, if a developer pushes a code, it should take the code, it should create an artifact out of it, a Docker image or something, and it should check whether his code is working or not, and it should give him the feedback saying, boss, your code is not working, you need to modify certain things or something like that. So for all that, in the AWS you have something called code build, code deploy, code pipeline, and code star, and all these things will help you out in deploying anything. So from the code build, it's a kind of Jenkins which will build your infrastructure within some time, and it will see that your application is up and running. So this screen tells you more about AWS development and DevOps services. Firstly, we have seen what kind of services AWS gives us. Next, we have seen what kind of security AWS gives us. Here we are seeing what kind of DevOps strategies that you can implement in the AWS. Now let's see. This is the main thing. Like in this course, these are all the things that we see. And let's see what all the things that we learn in this course. If I just come back here. So if you see, these are all the services that we have been talking about, EC2, auto scaling, and all these things. And in this course, I won't teach you something which is confined to a kind of data scientist or like big data or machine learning. For example, if you take elastic map reduce, it's completely related to the big data and data analysis. So the people who are already working on the data analysis, and if they want to understand the EMR, then the course would be they need to have the data analysis or big data course, and they can understand this. But in this course, I won't teach you EMR or kinesis or something like that. We'll go into these things. What are the fundamentals that even EMR, for example, even if a big data guy wants to use AWS, firstly they need to understand these things, only they can understand EMR. So this particular course will be again on the lines of solutions architect, where you can take up the cloud practitioner certification, or you can take up a DevOps or a SysOps or a developer, a kind of certification. So it's being aimed in that way. And these are all the database services. So I'll teach you EBS. We have looked into external storage called S3, right? So there is some other one called EFS, and I'll teach you all the ones that you see here. I'll give you the basics of Redshift. I will not go deep into that. And Elastic Cache, DynamoDB, RDS, will cover it. And here also in the networking part, so networking is also challenging. Like if you come to the cloud also, you have many things like creating the networking subnets, like routing parts, and how do you create an endpoints, and taking care of on-premise setup to cloud networking and all that. So for that, there are some services, I'll tell you that. And these are the management services. You have the CloudWatch, which will monitor the complete infrastructure and application. You have the CloudFormation, which will create the stacks for you, like the dev and QA, what we talked about. And you have Beanstalk, which is an application orchestration. I'll teach you this one, and I will not go to the ops work. We'll just go with the CloudWatch. Sorry, only CloudFormation. So other kind of services are these things, which are more related to the developers. we'll just touch these things like we can look into the code commit and code build, but some of the things we'll just see how they are utilized for the development. Okay, this is more about understanding the services and all this. And as I told you, the AWS shares a major market in the cloud. Like even if you look into the Gartner, how the every quarter which cloud performance a lot, like AWS at least shares to nearly 45 to 50% of the cloud market is being shared by the AWS. Next comes the Azure, next comes the GCP. So if you learn the cloud, you have an ample amount of opportunities. Like everyone is looking into the cloud, and the people are who are like, if you see the openings are around AWS as a more when you compare to the Azure and all that. So this course will give you all those things, and we'll it's not like only theoretical that we see. Like every day we'll go here to the AWS management console, and all the services that I have been showing you till now, and I'm trying to understand, I'm trying to give you the like what kind of things in an on-premise setup and how do you go to the cloud and all that. You can see all the services here, the S3, RDS, EC2 and all those. So firstly, we'll start the course with understanding the basic services first. So it comes to the compute part, where I'll tell you the normal VMs, how do you do the load balancing, auto scaling, if you want to increase the EBS volumes, how do you, all these things firstly you'll have in first 1 or 2 weeks. And next we'll come to the storage part, S3 and all that. And next we'll move into the database, and it takes around 3 to 4 weeks to come to this part. And next we'll have the networking, that is creating the VPC, CloudFront, and Route 53 DNS records and all these things. And one more important thing is these days, if you see, everyone is having these microservice architecture. So you either have a Kubernetes clusters, or you either have a kind of Docker images where you want to deploy. You want to have a kind of some kind of Docker host or somewhere where you can deploy the Docker and you run your business, right? So for this, AWS offers you two kind of services. One thing is Elastic Container Service, ECS we call it as, where you create the clusters and put your Docker images there. You are just running the uh, uh, you are just running the microservices. There is no need to check in anything. Like it's a completely fully managed service from the AWS. And now if you already have a Kubernetes on the on-premise, or if you're planning to move to the Kubernetes, then AWS has something called Elastic Kubernetes Service. So in this course, we'll look into container service and also the Kubernetes, at least the basic parts, because the Kubernetes in depth itself has a lot of things. Itself is a complete world. And we'll also see the ECR repository where you store the databases, and we'll see how these three things are integrated. So this is pretty much that we discuss, and all the other things are here. Like you have the CloudFormation, CloudTrail that we discuss, and there are other services like how do you manage the users and all that from the AWS IAM here. And there are other services, one or two here also. We'll pick them. So this course is being aimed at that, and every day I'll be trying to create along with you. So you'll just do whatever. Like I'll give you the tasks. I'll also give you the quiz every week related to one particular topic, which will give you a way to prepare for the certification. And I'll also give you the tasks, and we'll also discuss how to solve those tasks. Like I'll integrate everything day by day. Like next second week, you will see that the databases, VMs, and S3 buckets are integrated, and you build an application like WordPress or a Drupal to understand how good you can leverage all the cloud that you have. And all these accounts that you create are the free tier accounts. AWS gives you a completely free account to try to spin up a different resources and understand these services. But there is a kind of limitation, like what kind of service you need to spin up. Every day, once we talk about one particular service, I'll tell you what is a free tier that is associated to that and how you can practice that. Even in this course, I'll go with completely free tier itself. I'll not, you'll see that you'll not spend any amount for the AWS to learn all these things. And we'll also see how we can take up on those lines. So this is about cloud, and this is the importance of the cloud, why we need to move to the cloud. And this is not only for the only DevOps guys, like anyone can understand the cloud. And this course is internally like the AWS DevOps itself. So if you see this particular slides that I told, I will cover here. So if you go here, like the last things that you see here is these code build, code deploy, these are all the DevOps itself. So this is a CI/CD part. This is infrastructure as a code, we call it as, where you are creating infrastructure just using some YAML files or something like that. And you'll see the monitoring and all this. So it's like typically it's like a cloud administrator, cloud engineer, DevOps engineer, build and release engineers, and SRE. So these many roles are there for you to try it out, and this can upskill your current role, or it can also give you ample amount of opportunities outside. So I think so I covered pretty of the things like what I'll tell in the course and how I'll continue with the course. And if you have any particular doubts about what you're currently going with and what literally this course will help you out, then you can just ask me. I can't hear you if someone is already talking.
Sir, how many days of course duration?
Yeah, it will take around 5 to 6 weeks. Like you can think of around it would take around 40 to 45 days. Like maybe completely like we'll go with Monday to a Friday, like 5 days a week. So it may take you around 6 weeks.
Okay, sir. Thank you.
And in between we'll have some kind of as I told you, every session that I complete will have a quiz or a kind of questions I'll come up which is in the real time, and based on that we'll have our more and more understanding, and we'll have some kind of like mock interviews or something. If already you're working on some kind of technology and you want to move into the on-premise, we'll sit there and we'll understand the architectures around that. Okay.
Sandeep, it's a great demo.
Thanks, Anil.
Yeah, I would like to understand whether with this course, can we only target the solution architect associate level certification, or can we target on the professional certification as well?
A professional is something where it's like you need to have more of the real-time experience. So it needs more in-depth of one particular service and all that. So it would like we can only target in the kind of uh, like 6 weeks. We can only concentrate on solutions architect, which is actually high. So if you look, even the cloud practitioner or basic certifications also require these things. But I'm just targeting something above level so that you can cover all the other minimum certificates. So professional is someone who is already having the associate solutions architect and he has a real-time experience on the AWS cloud. Only he can crack it out.
Okay, got it. Thank you, Sandeep.
Thanks.
Sorry.
Okay, anyone, any other doubts that you have? So if you're already working on some kind of role in your career, and if you want to just ask me the questions that how can you upskill with this particular course, I'm ready to answer that all. Or you can just put that in the chat if you have any questions.
Yes, Sandeep. Currently, I'm working as a senior IAM Access Management Engineer at a major healthcare in US. And with this course, I just wanted to understand how we can leverage the IAM in AWS. It's not about the services which are offered in AWS for managing the IAM, which is about placing my application into the cloud application and how best we can able to manage it, and also how we can able to integrate the IAM solution with AWS to manage the cloud users and also cloud user certifications which are related to the cloud users and accesses to.
So you mean anything around the user management that you are speaking about?
Yes.
Yeah, AWS has a lot of services like which does all this user management. One thing is IAM, like firstly, if you have like AWS has something called AD. So if you look, Active Directory services are already there. So if you're already using some kind of Active Directory in your companies, and if you want to integrate this, AWS gives you a way to handle all that directory services. It can also handle the federated users. Like for example, you have a like for example, if you want to log into this console using a Gmail or Facebook, you can do that, or a Microsoft Outlook accounts and all that. Or if you want to have something around the application. Like let's suppose an application requires all the users and all that. So you want to use some kind of AWS thing to leverage all this. So you have something called cognitive, which is a customer identity management, and AWS credential or associated, like any federated identities again can come into this. And finally, you have IAM itself, which can be like AWS itself gives you this IAM user to like handle almost all the resources which are there in this. For example, if you want to access the RDS or a database, you can use an IAM. So you can combine all these things. You have multiple ways to have the user management from the AD to cognitive to the IAM. So everything is supported in the AWS.
Got it. But does it has any, does AWS can have ability to connect to the on-premise applications and
Yeah,
other
it
cloud
has.
applications too?
Definitely, like it's a hybrid kind of cloud. It has all the lines. So AWS has many ways. Like there is something called direct connect, or like you can have completely your databases on your on-premise setup, and AWS can use it. You have a data pipelines, and there are different services. Like whatever that you name it, it's possible in the AWS.
Got it. Does it has a capability to integrate with Oracle ERP or any other cloud applications? Oracle
Yeah,
cloud
it has.
application.
Yeah, it has.
Okay, got it. Yeah, currently we are using the SailPoint as IAM in our organization. So majorly we are planning to integrate AWS with a SailPoint to manage the
Okay.
cloud use because
Okay.
SailPoint, yeah. So yeah.
Yeah, thanks. So related to the networking, like if Aruna, you have asked the question, right? So AWS has all these kind of network features. It's even along with the cloud, you can connect to the on-premise networking, and you can create many things here. So if you see this particular networking, so here in this course, we'll understand how do you create a VPC, how do you create a subnet, routes that are associated to the VPC, and how do you create a kind of CDNs, and how do you create domain names, and how do you route the domain names, for example, facebook.com or example.com or devopslearning.com, and how do you route it to your a website which is already running on AWS servers. All these kind of networking components and everything we'll deal here. So we do have that in the course. So any other doubts? Okay, thanks everyone then. If you don't have any doubts, we can just end this class. I'll just stop the recording.